A. In the diagram, AC and BD are straight lines. Find the value of P and the value of Q. The question mentions that AC and BD are straight lines because it wants to remind you that the angles in a straight line add up to 180. So if you look at straight line BD, this means that angle P plus angle 48 must equal 180 degrees, and we can use this to find angle P. So angle P is equal to 180 minus 48, which equals 132 degrees. And when we have straight lines intersecting, the angles opposite are the same. This means that this angle over here must also be equal to P, and this angle over here must be equal to 48 degrees. So we can use the fact that if we look at this triangle, all the angles inside a triangle add up to 180 degrees. Therefore, we can write angle Q plus 55 plus 48 must equal 180, and we can use this to solve for Q. And if we do that, Q equals 77 degrees. B. The angles of a quadrilateral are x, x plus 5, 2x minus 25, and x plus 10. Find the value of x. So a quadrilateral is any four-sided shape. So I'm going to draw a random four-sided shape. The angles are x, x plus 5, 2x minus 25, and x plus 10. The sum of the interior angles of a quadrilateral always add up to 360. This means that if you add all these angles up, it must equal 360. And we can use this to solve for x. So if we simplify the expression, that's 5x minus 10 equals 360. And then you can use it to solve for x, so plus 10 to both sides. 5x equals 370, then divide both sides by 5. X equals 370 divided by 5, which is 74. So x equals 74 degrees. C. A regular polygon has 72 sides. Find the size of an interior angle. For a regular polygon with n sides, we know that the size of any exterior angle is equal to 360 divided by n, the number of sides, and the interior angle plus the exterior angle must equal 180. So if it has 72 sides, n equals 72. So the exterior angle must equal 360 divided by n. So 360 divided by 72 equals 5 degrees. And we know that interior angle plus exterior angle must equal 180. So if the exterior angle is equal to 5, this means interior angle plus 5 equals 180. That means interior angle equals 180 minus 5, which equals 175 degrees. D. A, B, C, and D lie on the circle center O with diameter AC. PQ is a tangent to the circle at A. Angle PAD equals 60 degrees. Angle BAC equals 20 degrees. Find the values of U, V, W, X, and Y. So, without telling us that A, B, C, D lie on the circle, we can already see that from the diagram. But they tell us that to remind us that, two, we have to use circle theorems for this question. It also reminds us that the diameter is AC, even though we can see that the diameter is AC, because it wants to remind us that there's a circle theorem that uses the diameter. And it tells us that PQ is tangent to the circle at A. Again, we can see that, but then it tells us that to remind us that there's a circle theorem we can use with tangents. So if we use a circle theorem with diameter first, Any triangle on the diameter and on the circumference of the circle is a right angle triangle. This means that diameter AC, so angle ADC over here must be 90 degrees. And if we use a circle theorem involving the tangent, a tangent makes 90 degrees with the radius of the circle at that point. So if this is the radius, that's the tangent. This means that this angle over here, angle OAC, must be 90, and angle OAP must also be 90. And when the question has multiple angles for you to find out, try and find it out in that order. It says find the values of u, v, w, x, and y. So try to find u first, v, w, x, then y, because most of the time you need the previous angles to work out the next angle. So if we find out u first, we can find out u from the fact that the angle over here, OAP, must be 90. Therefore, u plus 60 must equal 90. And therefore, we can solve for u, and u equals 30 degrees. Okay, after you find out an angle, try to label it on the diagram because it might become useful for the other angles. So that's 30 now. And then we want to find v. So for v, because we already know that u is equal to 30, we have all the angles inside the triangle ADC except for v, because we know that that angle over there is 90 degrees. So the angles inside a triangle add up to 180. That's u plus 90 plus v equals 180, where we already know that u is 30. So we can use this to solve for v. So v equals 180 minus 90 minus 30. So v equals 60 degrees. And we will label that on the diagram. Next, we should try and find w. So we use the circle theorems with the diameter and the tangent already. We can try to think of other circle theorems. And there's another circle theorem where if an angle comes from the same segment on the circle, the angles are the same. And if we look at point D and point A, these two angles come from the same segment. Angle V and angle W come from the same segment, meaning angle W equals angle V. And we just found out that angle V is 60 degrees. Therefore, W is equal to 60 degrees. And I will mark that on the diagram. Next, we need to find X. So another circle theorem that we could use is this one. So the angle at the center is double the angle at the circumference of the circle if they come from the same segment. Okay, the question also reminds us that the center is at O because they want to remind us to use that circle theorem. Right? So we can apply the circle theorem there. So this means that angle X must be double of angle W. So X equals 2W. So therefore X equals 2 multiplied by 60. So X equals 120 degrees. Now that X is equal to 120, all we need now is angle Y. So for angle Y, we can notice that OD and OC are the radius of the circle. So this is equal to this. This means that the triangle ODC is an isosceles triangle. So the angle ODC must be 60. So if we can find this tiny angle over here, or the angle BDC, we can find out the value of y, because y plus that angle must equal 60 degrees. So we need to find a way to find angle BDC. And we can use a circle theorem for that. The same circle theorem, the angles coming from the same segment must be the same. So notice that angle BDC comes from the same segment as angle BAC. This means that angle BDC is equal to 20 degrees. And now that we know that angle BDC is equal to 20, y equals 60 minus 20, so y equals 40 degrees. E. A, B, and C lie on the circle center O. Angle AOC equals 3x plus 22, and angle ABC equals 5x. Find the value of x. Again, it says that A, B, and C lie on circle of center O to remind us that we can use circle theorems. So these are some circle theorems. Because it doesn't mention any tangents and any diameters, I pulled the circle theorems that don't involve tangents and the diameter. And these are the other circle theorems. So if I try to apply these circle theorems, angles coming from the same segment don't apply to this one, because if I can apply it, then I could apply to an angle like this, and that would be 5x. But then angle AOC is at the center, so we can't apply it to that one. If I try to apply the circle theorem for the center and the circumference like that, that means that if I draw another line from segment AC in the same direction as the center, like this, the angle over here must be half of the angle at the center. So the angle over there is 3x plus 22 divided by 2. According to that circle theorem. And then we can also try and use the other circle theorem, where for a cyclic quadrilateral, the opposite angles add up to 180. And now that we drew that extra blue line, we now have a cyclic quadrilateral. So opposite angles in a cyclic quadrilateral add up to 180. This means that the angle on the other side, which is 3x plus 22 divided by 2, plus 5x must equal 180. And now we can use this equation to solve for x. Okay, and if we do that, we can multiply both sides by 2 to get rid of the fraction first, and then solve for x. I can then move 22 to the other side by doing minus 22. And then I can remove the 13 by divide by 13 to both sides. So that's x equals 338 divided by 13, which equals 26 degrees. So x equals 26 degrees.